Hello everyone, welcome back. In this particular video, we're going to start talking about the oxidation reactions of alcohols. Now, these reactions are the opposite of the reduction reactions that we've previously seen. And what happens in these reactions is that the alcohol is converted into the corresponding carbonyl compound. Now, what do we mean by that? It really depends on the alcohol that we're going to start out with. And not all alcohols can be oxidized. That's something else that we're going to see here. Okay, so primary alcohols, I've drawn the general structure of a primary alcohol here. And the key thing to notice here is the number of alpha hydrogens. Just as a quick review, an alpha carbon is defined as a carbon that's connected to the functional group. So as far as an alcohol is concerned, the hydroxyl group is our functional group. So the carbon that's connected to it is the alpha carbon. And notice how a primary alcohol has two alpha hydrogens. So a primary alcohol can be oxidized twice because oxidation, in a very visual sense, you can treat the oxidation as the removal of hydrogens or the formation of more carbon-oxygen bonds. Okay, so a primary alcohol can be oxidized twice. We denote oxidation by putting an oxygen inside square brackets. Okay, once you put it inside square bracket, that's sort of denotes oxidation. So the first oxidation of a primary alcohol is when it's converted into an aldehyde. Okay, notice what happened is we've converted that hydroxyl group into an oxygen. We've put a double bond between the alpha carbon and the oxygen, and we removed one of the alpha hydrogens. So that's one oxidation. And the primary alcohol can be further oxidized into the carboxylic acid, where this second alpha hydrogen is also removed. So you're removing hydrogen and you're adding an oxygen. So that's an oxidation. So as I mentioned earlier, in the first case, what's happening is we're removing hydrogens and we are adding carbon-oxygen bonds. It was a carbon-oxygen single bond, and now it's a carbon-oxygen double bond. So in principle, we've increased the number of carbon-oxygen bonds. So that's an oxidation. So we get the aldehyde. So primary alcohol can be first oxidized into an aldehyde, and then a complete oxidation of a primary alcohol would give us a carboxylic acid as our end product. Coming to secondary alcohols. Secondary alcohols have only one alpha hydrogen. That means secondary alcohols can only be oxidized once. Okay, so when we oxidize secondary alcohols, we're going to do pretty much what we did with the primary alcohol for the oxidation. We're going to remove the alpha hydrogen. The hydrogen on the oxygen is going to be gone. And so we'll put a double bond here. That's the alpha carbon, we have the oxygen. So secondary alcohols, when they're oxidized, they are going to give us a ketone as the product. Tertiary alcohols, on the other hand, in contrast to primary and secondary alcohols, they do not have any alpha hydrogens, which means these cannot be oxidized. Okay, so there's no oxidation possible for tertiary alcohols. Now, you can add oxygens, but you cannot do that without destroying the carbon skeleton. If you break some carbon-carbon bonds, you might be able to add further oxygens, but then that does not preserve the carbon skeleton. So that's why we're keeping those reactions out of the scope of what we're discussing right now. So these are reactions where the carbon skeleton is preserved. We're not breaking any carbon-carbon bonds. We're only breaking carbon-hydrogen bonds, and we're making carbon-oxygen bonds, okay? So just to summarize, primary alcohols can be first oxidized into aldehydes, further oxidized into carboxylic acids. That would be the complete oxidation. Secondary alcohols are oxidized into ketones, and tertiary alcohols cannot be oxidized. And this is the reverse of the reduction reactions that we saw earlier. Because remember, aldehydes, they are reduced. Okay, so if we reduce them, which is by using reagents like sodium borohydride, that was a reduction reaction. Aldehydes are converted into primary alcohols. Similarly, ketones, when they are reduced, example with sodium borohydride, they are converted into secondary alcohol. So this is the opposite of the reduction reactions that we saw earlier. In the next video, we will go into the details of some of the reactions or some reagents that are used for oxidizing primary and secondary alcohols to the corresponding carbonyl compound or to a carboxylic acid further. Okay, so when it comes to a primary alcohol, you get the carbonyl compound, and then the carbonyl compound can be further oxidized to a carboxylic acid. But this is only for primary alcohols. Okay, that will be our next video. Bye.